Okay, hello everybody. We're going to talk about graphing sine and cosine functions on the x and y axis. And to help us set this up, if you recall, one of the things that we did way back when was at section 5.4, not that way back, we talked about the idea of the unit circle and the values of sine and cosine on those functions. So if we thought about what was happening right here, we could say that, well, as we allowed the value of t, that is the angle, to increase or decrease as we went around that circle, well, as that value of t increased or decreased, we would see that the sine or cosine adjusted accordingly. So for example, right here, I'm going to do this in red. We say that y right here is the sine of the angle t, or the arc length t, in our unit circle. So what happens? Well, at 0, the sine is 0. At pi over 6, we know that the sine is 1/2. At pi over 4, the value is square root of 2 over 2, about 0.7 or so. At pi over 3, the value is about 0.86 or so, which is the square root of 3 over 2. And at pi over 2, we're at 1. Now, if we trace this progression as we went around, here's what would happen. Our graph would follow the same pattern all the way around, and at pi, go through 0. We'd trace some negative values here underneath the x-axis as we went down. We'd see at 3 pi over 2, we would get -1. And then finally, just tracing these points as they decreased, we would say at 2 pi we got 0, and we would start the entire pattern over again. And so for one full circle, following our length of our red line right here, we would see a graph that looked roughly like this. At 0 goes through 0. At pi over 2 goes through 1. At pi goes through 0. At 3 pi over 2, we get -1. And at 2 pi, we get back to 0, and the graph in one cycle looks like this. Now, what about that sine graph? Well, if we look at the sine function, right, we say cosine function, x, the x values right here were the cosine of the arc length t on our unit circle, and so that's what we'll say right here. So what happens? Well, we found here that at 0, the cosine is equal to 1 this time. What happened at pi over 2? Well, at pi over 2, our cosine was 0. And it's as if what I'm doing right here is I'm taking the arc length and laying it flat along this axis right here so that I can see what's going on. So let me scoot this up so I can see what's going on, in fact. We know that at pi, the cosine is equal to -1. So I'll put -1 right here. Cosine of pi is -1. At 3 pi over 2, we're back to 0, and then at 2 pi, we're back to +1. So in one cycle, our cosine function would follow this set of steps. And all we're doing right here is we're following the horizontal line formed by our right triangle, right? So as we go from 0 to pi over 2, the value of x decreases from 1 to 0. Then at pi goes to -1, which is back here. Then at 3 pi over 2 goes to 0 again. Then finally at 2 pi goes back to 1. So we would be passing through points like pi -1 here. Then 3 pi over 2, 0. and then finally at 2 pi back to positive 1. So in fact, this gives us two certain kinds of functions that we can talk about. This graph right here that we've just traced sideways is in fact the cosine function. And I'm going to change its perspective right here and move it around a little bit here. Whoops. See if it'll go with me. There we go. So let's shift around some of these things right here. Pi negative 1. Oops. Let's move this graph back where it is right here. Pi negative 1. Let's move some of these points where they go. Make it look like we've got our points all in the right place here. I have to align everything. Okay, so our graph, and when we turn it sideways, looks kind of like this. And there's a lot of similarity between the graph above it and the graph below it. So these are pictures of our sine and cosine functions as we're going to deal with them. So let's get to what that's going to look like here in the next video.